All right, we have one final condition to look at. We've been looking at side, angle, side, uh, side, 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 angle, side, angle, 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 side, 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 angle, and angle, angle, angle conditions in Euclidean, hyperbolic, spherical, and taxicab geometry. And we only have one left to do, and that's the angle, angle, angle condition in taxicab. So let's take a look at that condition. All right, in taxicab geometry, if we know two triangles, we know that the third angle, we know what the third angle is because the three angles must add up to, their measures must add up to pi radians or 180 degrees. It's just exactly the same as Euclidean geometry for that. So right off the bat, if you give three angles and they don't add up to pi or 180 degrees, then whether they're bigger or smaller, then there are no triangles possible with those measurements, so zero congruence classes. But what happens if they do add up to pi like we have here? Start by specifying the first angle. Next, specify the second angle. And then the third one. There's a triangle. Well, look what happens. Once again, we can move it just like we did in Euclidean geometry, so there are infinitely many congruence classes. But it's even worse than Euclidean geometry, because if we have another one here, let's say, and we move this, these are the side links here and here, not only are we can clearly see that we get infinitely many different things. When we look at the ratio of the sides, they're not the same. They have to, if they're sort of oriented, if I could get this side parallel to that side, and then that would be parallel to that, then they would be, in fact, proportional. But if they're not, if they're at a different angle like this, so those have all the angles congruent to the angles here, corresponding ones, but not only are the sides different, they're not even in proportion. So we have infinitely many congruence classes there, once again in the taxicab geometry, but this time, unlike Euclidean geometry, they're not even necessarily similar. I'm not saying there are not any similar triangles in this geometry. There are some similar triangles, but they are not necessarily guaranteed to be similar in this with just having two angles. Okay, so there won't be in Euclidean geometry we're going to have an angle-angle similarity theorem. There's not going to be an angle-angle similarity theorem for taxicab geometry.